For nearly half a century, Voyager 1 has traveled farther from Earth than any spacecraft ever built. Launched in 1977, it has crossed the outer planets, escaped the Sun's protective bubble, and entered the vast region between the stars. Today, billions of miles from home, it continues sending faint radio signals that take more than 20 hours to reach Earth. Every transmission represents a glimpse into a place no human has ever visited. Over the years, Voyager has become the center of countless online stories. Some claim it has detected mysterious objects, unknown signals, or even evidence of extraterrestrial intelligence. These dramatic ideas spread quickly because they tap into one of humanity's oldest questions: what exists beyond the edge of our solar system? The truth, however, is both more careful and more fascinating. Voyager was never designed to search for alien civilizations or photograph distant worlds. Its cameras were switched off decades ago to conserve power. Instead, the spacecraft relies on scientific instruments that measure its immediate surroundings, recording magnetic fields, plasma, cosmic rays, and charged particles drifting through interstellar space. Those measurements have already transformed astronomy. But before reaching this lonely frontier, Voyager completed one of the greatest exploration missions in history. Taking advantage of a rare planetary alignment, the spacecraft visited Jupiter and Saturn, revealing discoveries that forever changed planetary science. At Jupiter, Voyager captured enormous storms larger than Earth itself and discovered active volcanoes erupting across the surface of the Moon Io. It was the first confirmed volcanic activity ever observed beyond our planet. At Saturn, the spacecraft exposed the breathtaking complexity of the planet's rings. What appeared smooth through Earth-based telescopes turned out to be thousands of delicate ringlets shaped by gravity and the constant influence of Saturn's many moons. After completing those historic flybys, Voyager's mission entered an entirely new phase. Instead of studying planets, it became humanity's first explorer of the outer boundary surrounding our solar system. For decades, scientists debated where the Sun's influence truly ends. The solar wind, a continuous stream of charged particles flowing outward from the Sun, creates a giant protective bubble known as the heliosphere. Beyond that invisible frontier lies interstellar space. In 2012, Voyager crossed the heliopause, becoming the first human-made object to enter this unexplored environment. The crossing wasn't marked by a wall or a dramatic visual event. Instead, scientists recognized it through gradual changes in plasma density, energetic particles, and magnetic field measurements. Suddenly, Voyager was sampling material that originated not from our Sun, but from the vast Milky Way itself. That achievement alone secured its place in history. Since then, Voyager has continued measuring the interstellar medium, revealing that the space between stars is far from empty. It contains plasma, magnetic fields, cosmic radiation, and the lingering effects of ancient stellar explosions that occurred millions of years ago. Every reading helps scientists understand how our solar system interacts with the galaxy around it. Occasionally, unusual patterns appear in the data. When they do, engineers carefully examine every possibility. Is the signal produced by natural plasma waves? Could it result from changing magnetic fields? Is it caused by aging spacecraft hardware? Or does it reveal something entirely new about interstellar space? Finding the correct answer requires months of careful analysis. Extraordinary claims demand extraordinary evidence. That scientific discipline is what has kept the Voyager mission valuable for nearly 50 years. Even today, this remarkable spacecraft continues to surprise researchers, not by confirming sensational internet theories, but by revealing how little we still know about the immense region beyond our solar system. And as Voyager continues its lonely journey through interstellar space, its most important discoveries may still lie ahead. After entering interstellar space, Voyager 1 began exploring a region no spacecraft had ever sampled before. For decades, astronomers imagined the space between stars as a vast, nearly empty void. Voyager's instruments painted a very different picture. Instead of emptiness, the spacecraft detected a dynamic environment filled with charged particles, plasma, magnetic fields, and energetic cosmic rays racing through the galaxy at incredible speeds. One of Voyager's most valuable discoveries came from its plasma wave instrument. Rather than capturing images, this instrument measures tiny vibrations moving through ionized gas. Scientists analyze these waves to estimate the density and structure of the interstellar medium. Sometimes these measurements are converted into audio, creating what many people describe as the sound of interstellar space. Although these recordings may seem mysterious, they are not voices or artificial transmissions. They are natural plasma oscillations produced by the interaction of charged particles and magnetic fields, a phenomenon predicted by physics and confirmed through careful observation. As Voyager continued its journey, another surprising pattern emerged. The density of interstellar plasma was not constant. Some regions appeared slightly denser than expected, while others showed gradual changes in magnetic field direction and cosmic ray intensity. These variations suggest that the space between stars is structured rather than uniform. Scientists believe these invisible boundaries were shaped over millions of years by stellar winds, ancient supernova explosions, and enormous magnetic fields stretching across the Milky Way. Every new measurement helps researchers build the first direct map of our local interstellar neighborhood. Unlike telescopes that observe distant objects, Voyager studies only the environment immediately surrounding the spacecraft. That limitation is also its greatest strength. Instead of relying entirely on distant observations, scientists now have direct measurements from a probe actually traveling through interstellar space. Keeping Voyager operational has become one of NASA's greatest engineering accomplishments. Its radioisotope power source slowly produces less electricity every year. To conserve energy, engineers have carefully switched off non-essential systems while keeping the most important scientific instruments running for as long as possible. Despite being nearly 50 years old, Voyager continues functioning in one of the harshest environments imaginable. Occasionally, mission controllers receive unusual telemetry or unexpected computer behavior. These events are usually traced to aging electronics, software issues, or high-energy cosmic rays affecting onboard systems. Because Voyager is now so incredibly distant, solving even a small technical problem requires extraordinary patience. A command transmitted from Earth takes more than 20 hours to reach the spacecraft. Another 20 hours pass before engineers receive its response. A single troubleshooting procedure can take several days to complete. Even with these challenges, Voyager continues sending scientific information unavailable from any other mission. Beyond its remarkable discoveries, Voyager carries something deeply symbolic. Attached to the spacecraft is the famous Golden Record, a gold-plated archive containing music, natural sounds, greetings in dozens of languages, photographs, and messages representing life on Earth. It was created not as an expectation of contact, but as a hopeful expression of humanity's curiosity and culture. Perhaps no one will ever discover it. Or perhaps, millions of years from now, another civilization may encounter this silent messenger drifting through the galaxy. Eventually, Voyager's remaining power will be exhausted. One by one, its instruments will shut down. Its final signal will fade into silence. Yet the spacecraft itself will continue its endless journey, orbiting the center of the Milky Way for millions of years. Its greatest achievement is not proving extraordinary theories. It is something even more inspiring. Voyager became the first human-made explorer to leave the solar system and directly investigate the space between the stars. It transformed scientific predictions into real measurements. It showed us that the galaxy beyond our sun is active, structured, and filled with discoveries waiting to be understood. And perhaps Voyager's most important lesson is this: the farther humanity explores, the more we realize how much remains unknown. Every answer opens another question. Every new frontier reveals an even larger one beyond it. As Voyager continues its silent voyage through interstellar space, it reminds us that exploration is not about reaching the end. It is about discovering that there is always something more to learn.